Hello and happy Thursday. Today we're looking at simplifying fractions. So kind of a big goal here. Simplifying fractions is super important and something that's going to come up throughout this entire chapter and kind of moving forward throughout your entire kind of math career. So simplifying fractions, kind of two words. Sometimes we call it reducing. So you might also see the word reduce means the same thing. So reduce or simplify fractions. So that's our main goal for today. So please use your notebook to take notes on everything that I'm going through today. If you need to pause the video so you have more time to write stuff down, please do that. So everything that's kind of written on my screen should be written down also in your notebook. So we're going to start with just a little bit of kind of fraction knowledge. So we know there's always two parts of a fraction and then the line in between, right? So we call the top part the numerator, fancy word, right? Numerator for top part. The bottom one is called the denominator. Okay, struggling there. Okay. So any number can be made into a fraction by adding a denominator of 1. So this is super important. So any number really could be a fraction if it's just over 1. So if we think about the number 2, if we wanted to do something with other fractions, we could make it a fraction by writing 2 over 1. Or if we had just the number 3, right, we could just add 1. It means the same thing. It still means 3. It's just a way to kind of make it look like a fraction. Negative fractions can be represented in like 3 different ways, and they all mean the same thing. So you can either have negative 1/2, or negative 1 over 2 like that, or 1 over negative 2. These all mean the same thing, okay? So nothing different about those. They all mean the exact same thing. Equivalent fractions. So this is super important. There's lots of different fractions that can be equivalent. Remember, equivalent kind of sounds like equal, so equivalent fractions are just equal. So kind of back to our reducing, simplifying, basically what we're doing when we're simplifying or reducing a fraction is we're writing an equivalent fraction. So if we had the fraction 1/2, like we've been using, we could multiply the top and bottom by the same number and make any amount of equivalent fractions. So let's say we multiply these both by 3. 1 times 3 would give me 3. 2 times 3 would give me 6. That's an equivalent fraction. These two fractions are equal. They mean the same amount. They both represent 1/2. So this would be an equivalent fraction. So another example, if we had the fraction 1/4 and we multiplied those both by 4. 4 times 1 on the top would give me 4. 4 times 4 on the bottom would give me 16. Again, equivalent fractions. They mean the same exact thing. So heading on, now we're looking at kind of the reducing part. So it's sort of a big process and there's lots of steps involved here. Very important though that we're kind of making sure that we're following along and taking notes in your notebook. So when we reduce a fraction, step 1 is to find the greatest common factor of each the numerator and the denominator. Then step 2 is divide both the numerator and denominator by that GCF. So we're going to start with example A here, 12 over 18. So we need to start by writing down all our factors for 12 and our factors for 18. I like to do this by making a factor tree like this. So each 2 branches that come from that number are 2 numbers that multiply to that number. So we can kind of look on our multiplication chart and find anything that multiplies to 12. So let's say we did 6 and 2. 2 is a prime number, so I circle it. No more branches from that one. Then this one I'm going to do 2 times 3, right? Because 2 times 3 is 6. 18, we're going to do the same thing. So 3 and 6. And then 2 and 3. So now we just write down each of the factors that we have in common. So if we look, we have a 2 in both of them and a 3 in both of them. Then our other number is a 2 and a 3, so those are not in common. And we don't care about the ones that we didn't circle, so those 6s we don't really care about. So then everything that we saw that we have in common, we'll write down out here. So we had a 2 in common and a 3 in common. When we multiplied those together, we get 6. So our GCF is 6. So then we go back to our fraction. We're going to just divide both these by 6. We are going to get 2 on the top and 3 on the bottom. So our reduced fraction is 2 over 3. All right, let's look at example B. So same thing. Now we got bigger numbers, right? 42 and 56. So let's say we don't want to do all the steps that we did up here and find our GCF. We're just like, I think I know some numbers that go into both of those, right? So we can brainstorm using our calculator or using our, brains, using our multiplication chart, and we realize, oh, I think 7 goes into both those. So let's try dividing them both by 7. Okay, so if I divide 42 by 7, I'm going to get 6. And then if I divide 56 by 7, I'm going to get 8. So we did reduce our fraction, right? It's smaller, but it's not all the way reduced. If we look at these two numbers, we might notice 2 still goes into both of them. So I'm going to reduce them again, divide them both by 2. So 6 divided by 2 is 3, 8 divided by 2 is 4. So our fully simplified or fully reduced problem is 3 over 4. So we're going to look at a couple more examples, and then for your assignment today, so the rest of this assignment is practicing reducing or simplifying fractions. So I'd head over here. We're going to start with question number 1. So number 1 here, we can see kind of clearly, right? 10 and 50 have a common factor of 10. So I'm going to divide them both by 10. 10 divided by 10 is 1. 50 divided by 10 is 5. Fully reduced, 1 over 5. Anytime we get a 1, we know definitely we're fully reduced. Question number 2, 16 and 48. So I might not know right off the bat what numbers go into both those, but I notice 4 goes into both of them. So let's divide it by 4 first. 16 divided by 4 is 4. 48 divided by 4 is 12. Is it fully reduced? No. We can also divide these by 4 again. So 4 divided by 4 is 1. 12 divided by 4 is 3. So 1/3 is our fully reduced fraction. So 80 and 980. I don't really know right off in my head what goes into both those. So I feel like a good guess, though, would be maybe 80. So let's divide them both by 80 and see if it works. So 80 divided by 80 would give us 1. 980 divided by 80 gives us 12.25. We don't want decimals. So if that happens, we know we chose the wrong number here. Okay, so that number did not work. So I'm going to erase this and try a different number. What about just 10 maybe? I know 10 is going to go into both those. So let's try doing that first. So 80 divided by 10 is 8. 980 divided by 10 is going to be 98. Now, same thing, right? Not really sure. So let's think about maybe, does 2 go into both those? Probably, right? So I'm going to divide them both by 2. 8 divided by 2 is 4. 98 divided by 2 is 49. Okay, 49's only factors are 7 and 7. So 7 doesn't go into 4. So now we're finally fully reduced. Number 4, 15 and 45. So we might notice these both have some common factors, right? Any number that ends in 5, like 15 and 45, definitely has 5 as a factor. But 15 also goes into both those numbers. So I'm going to divide these both by 15. 15 divided by 15, 1. 45 divided by 15, 3. All right. Number 5, so 13 and 26. This is kind of a hard one, right? You kind of have to check and see. So, fun fact, 13 goes into both those. Okay, so those you wouldn't be able to find on your multiplication chart. You would have to kind of figure that out. So again, just try some numbers in your calculator, right? If you're not sure, just start trying numbers. And then 17 and 85, again, right? Not really sure. Let's try 17. Because somebody made these problems for a reason. So 17 does go into both them. So we get 1 over 5 for that last one. All right. Good luck and reach out if you have any questions.